Okay. Here we go. Do you remember the Pythagorean identity?
Yes.
Okay, cool. Sine squared is 1 minus. Okay. So your answer to that was no. I don't remember the Pythagorean identity. Sine squared is 1 minus cosine squared, and cosine squared is 1 minus sine squared. Yay? You will need those today when you go to integrate. Now, this is a typical example of the problem of the day, sine cubed integrated. So the most logical jump to conclusion is people just say, well, why not just use the power law? Why not this? Why not that? If you check it, what's the derivative? 4 comes down, drops to 3, but then you pick up a cosine. Obviously, there's a chain rule component to that. That does not work. Can we all agree that integrating sine cubed is not sine to the 4th over 4? Does not work. Okay. No. So, the idea on such a deal is you set up a u sub problem. So break it up into sine squared and sine. Now that sine, the single powered sine off to the side, that's going to be du. Now if du is sine, then that means u needs to be cosine. That means then we're going to need to change that guy to 1 minus cosine u by, x squared. Not 1 minus cosine squared of x. By identity, that's 100% allowed. Sine squared is equal to 1 minus cosine squared, so I'm not breaking math. That's fine. Now we can use sub. What shall we let u equal? 1 minus, I think that's a bit of an overreach. Just cosine. Okay, so let u equal cosine. Du is negative sine. Like always, if our du doesn't perfectly match, then we need to do something about it. We don't have a negative one. We need to move that over. You with me? All right. So when we substitute, what do we get? 1 minus u squared, but then a negative du, right? Are you with me? So maybe if I take that negative and multiply it in, then that's the same as u squared minus 1. Okay. All right, what's the antiderivative of u squared? 1/3 u cubed minus u plus c, and am I done? No, sub back 1/3 cosine cubed minus cosine plus c. If we were to check that, if you wanted to check that, you would see that it's 1/3 times 3 cosine squared times a negative sine plus a sine, and with a little bit of substitution, cosine squared with 1 minus sine squared, it would eventually get there. Yes, 1 minus sine squared. Now I feel like I need to prove that negative sine plus cubed. Are you seeing how it's working? Good. Okay. All right. It does check out, in other words. Trust me. Let's go to slightly harder, because this has a little more of a u sub component to it, but it's no big deal. What would you reckon we do? Split off. So anytime you have an odd power, you split off a single cosine to the first, which will serve or du later. You with me? So we have cosine squared of 4x times cosine of 4x. I think you'll agree that that is sound math. Cosine cubed is cosine squared times cosine. We? Now what do we do? It's the identity. 1 minus sine squared. It's all good as long as the argument is the same. So it's 4x. That times the cosine out there. We're good. All right. Now what do we let u equal? Sine squared or just sine? Sine of 4x. What's du? 4 cosine of 4x by g, right? Yes, but the 4 needs to be moved so we can sub for the cosine that we have. Are we cool? Subbing in the brackets, instead of 1 minus sine squared of 4x, I have 1 minus u squared. Instead of cosine of 4x dx, I have u over 4, or you could put a 1/4 out front if you want. You cool? Alrighty. Anti-differentiating. What's the antiderivative of 1? U and u squared? 1/3 u cubed plus c senor, and finally sub back 1/4 of sine of 4x minus 1/3 sine cubed of 4x. Are we cool? Okay, is this going okay? Bending. All right. A little grosser is an odd power that's a little bigger, cosine to the 5th. But it's all good because you're so darn smart, we'll be fine. What should I do first? Split it. Split it in 2.
Squared and cubed.
Okay, squared and cubed. I'm going to go one better. Squared, and 1. Okay, the 1 will be our du later. If this, the single powered one is going to be du, if this is du, then we need all else to be u, and therefore sine-ish stuff. So we need to jump to sines. What do I put in place of cosine squared? 1 minus sine squared and 1 minus sine squared. Now here's where you're not gonna break my heart now and say this is 1 minus sine to the 4th, because then I'll have to walk over to Mrs. LeBlanc's class to review foiling. First is 1. Outer is negative sine squared. Inner is negative sine squared. So the oi is negative 2 sine squared, and the o plus sine to the 4th. We first, outer, inner, class. Taught all throughout America, not just in our school. All right. U, what is it? Sine. Du. Cosine. With substitution, my new integral is 1 minus 2u plus u squared, plus 2u squared plus u to the 4th du. Didn't have to do much to get my du. Yeah? Antiderivative? U minus 2/3 u cubed plus 1/5 u to the 5th plus c, and sub back and we're done. U is sine of x minus 2/3 sine cubed of x plus 1/5 sine to the 5th of x. Are we cool? Are you with me, people?
Yes.
Okay. Again, just little variations on the theme. So, in this case, you should always, when you get multiple terms, you should always focus on the odd term, because that's the one you're going to split up. You're not going to split up cosine squared. It's great the way it is. You want to split up the sine cubed, like I did there. All right. So when you do that, the question then is, okay, I have sine squared and cosine squared. Which one should I replace? Okay, you say the sine squared. I agree. Why do you say that? Yeah, your du is going to be sine, so you need all else to be cosine. Are you with me on that concept? Okay, so we're going to leave the cosine squared. We're going to replace the sine squared with 1 minus cosine squared. Okay, now it's up to you whether you distribute first and then u sub, or u sub then distribute. It's your call, which it's fine either way. What do you want to do? Distribute first. Okay, so cosine squared minus cosine to the 4th. When I say distribute, obviously I just mean the cosines. Don't distribute the sine. That's bad. Okay. U is? Say what? Cosine. Du is? Negative sine. Obviously that negative requires some degree of care. So the integral becomes u squared minus u to the 4th, but times the negative du. And so if you did a little switch of the signs, it's more like u to the 4th minus u squared du. What is the antiderivative? 1/5 u to the 5th minus 1/3 u cubed plus c, and therefore 1/5 cosine to the 5th minus 1/3 sine cubed plus c, not sine, cosine. What? There you go, man. All right, are you with me? Okay, last problem, I think. Yes?
Yes.
All right, this we're going to split up and do this 2 separate ways. Here's the deal. When they're both odd, it's your call which one you split a single off of. So this is what I'd like you to do. The gentleman in the house, if you are indeed a gentleman, I would like you to split a single cosine off. You with me? The ladies. All the ladies in the house. The ladies. Cosine, leave it. Sine, split it. You down? And then proceed from there. We will get slightly different answers, and I need to communicate how they're slightly different and how they're really the same. Guys got chef. Oi, oi. Occasionally. Okay. All right, gentlemen, did you get what I got? 1/4 sine of the 4th plus 1/3 sine of the 6th plus 1/8 sine of the 8th. Okay. Plus C. It was a bit of a mess, and that's because we split up the larger one, which meant we had to square cosine squared. It was a mess. I believe the ladies got it easier because by taking a sign off, this is a much easier identity that you didn't have to square. This is a heck of a lot easier. Now, surely these answers look different, and yet if you replaced sine squared with 1 minus cosine squared, they would eventually match, though the c's would be different. They would have different c's. But I can assure you they are the same. All right, that is that. So I don't know if I communicated clearly what was due and when it was due. So do you still have 74B or? Yes. Okay, so 74B and 75. If you've already turned in 74B, awesome, good job. If you want it back, I haven't graded it yet, so let me know. But let's do 74B first. Is there anything, do we finish 25? All right, that's a hard one. We'll go with that. What else on 74B? What? 23. 16. 3. 3. 20. Okay, let's call that good. All right. Okay. It is 25. Where did we leave off? 25 C or D? D. Okay. So in 25, on 74, so is x plus 2y squared equals 6. Now, just so we're clear on the big idea of things, this is a conic family. Okay, so that equation governs all conics. Circles, ellipses, hyperbolas, parabolas, and points and lines in some cases, all right? Depending on what A, B, C, D, E, and F are, and whether they're there or not at all, you get totally different figures. This, once you're in the know, you'll see that. If you see that in a conic, you think, oh, here we go. Because this one, this XY mix, that causes rotation of axis. And so an XY in the mix might cause an ellipse to open this way, or a parabola to open at an angle, or a hyperbola to open at an angle. It's hard to graph those because they're non-functions, I think you'll agree. And so in part D, just so you're clear what the heck you're doing, always say, why am I doing this? D, when they say what's y, they're trying to say, all right, how can you put it in a form that you could actually put it into your calculator graph? Because that, not so much, although nowadays the Inspire does do relations, and that's great. So the point of D is solve for y so that you could get a function. All right? Now, this is hard to solve for y. If that was not there, would you agree it would just be moving stuff around and square rooting, yeah? No big deal. But when that is there, things are a lot harder because now you have an x, a y squared, and a y. It's hard to solve for that. Well, that's why you either need to deal with this solving for y by either completing the square, which students tend not to want to do, but I'll be happy to do it, or using the quadratic formula in a little different way than you're used to. Now the book says quadratic formula, so I assume that's the way you try to do, so I'm going to go with it that way, right? So anytime you do a quadratic, you want everything together. I understand there's x's and y's, but you're thinking of y as the variable you're doing the quadratic formula on, and x is more like a constant, right? So 2y squared is first, xy, or the y to the first term is second, and anything that doesn't have a y in it, which would involve x minus 6, that's last. Now this, in the quadratic formula, there's a, there's b, and this whole thing is c. Y then is, when I say negative b, it's actually negative x. And I know that's weird to not see a number there, but it is what it is. B squared is x squared minus 4a is 2, and c is x minus 6 over 2a is 4. Now, if you were to then put that into the calculator, you would see one of the conics. I wish I would have put this in ahead of time. I don't. It feels like parabola, but there's actually, it's a little complicated when this is there. Some things change a little bit, so it's hard to say. I'd be tempted to say parabola, but it could be inverse. Anyway, that's the point. You're supposed to put it in your calculator and graph it. Are you on your way from there? Because of the plus or minus, you can't put it in one equation. You have to put it in F1 and F2. Are you with me? Shall we continue on? All right, I'll assume that you can put that in your calculator. 23. 23. We didn't do 23? Okay, so there's two problems here. There is what is the relationship between price and quantity sold? And then after you get that, then you can do revenue is price of each times quantity sold. Are you with me? Okay, but I can't get to maximizing revenue until I get the quantity sold function. So in this relationship, they say when you set the price at 100 cents, they say later make it cents. Okay, so make it 100 cents, and quantity sold was 1,000. Very cool. Now consider then what happens when they change. They say every time you jack up the price by 20, so I'll make that a case of 120, the sold goes down to 900. Now that change rate is always the same if you jacked up the price again, 20 cents. You would lose another 100 sales again. Now, if the change rate is always the same, what kind of function do we know that is? It's a linear function. Yeah, if a constant rate of change is a constant derivative, and lines have constant derivatives. You with me? Okay, cool. So now we need to write the relationship to that. Let's start with a slope. What's the slope? Negative 100 for the rise and over 20. So negative 5 is the slope. Are we down? Okay. There are many points shown, but you should probably use the one that you can feel most confident, and that's the one they gave you. So what's the point they give you? 100, 1,000. Now I would normally write an equation this way. but in this case, I'm not using X and Y, I'm using price and quantity. So, you down? So I'm feeling more like Q minus Q1 equals M times P minus P1. Would you put in the point and the slope? Q minus 1,000 equals -5 P minus 100. If I clean that up, normally I don't care about point slope form, but we are going to use it later on, so let's clean it up. Q is -5P, and then I'd get a plus 500 and a plus 1,000, so I get a quantity sold of -5P plus 1,500. Lee? All right. What is the, so that's the first part. Therefore, the revenue, depending on what price you set, different prices would yield different revenue. So what's my revenue equation? What's the price of each? Is it 100 or is it varying? It's varying. Okay, so that's P. And the quantity sold, that's Q. Now, we want to maximize revenue is the point later. I don't think they actually asked me to maximize revenue in this question. But because we don't like to take derivatives on two variables, they say at the end, then sub, so it's all one variable. So how can I make it all one variable? Sub in the Q, you just put together, and then you get a revenue equation that's super duper easy to work with, and then obviously you're home free at that maximizing revenue if they had asked, which they did. You with me? That's a hard problem. In business calculus, you would do many of those problems. Okay, 23, check. 16. Is 16 a question? Still, person? 16. 3 tangents. Okay, this is definitely worth committing to memory. But what's the process of developing the antiderivative of tangent? Sine over cosine. All right, so if you let it be sine over cosine and then u sub it, u is cosine, du is negative sine, which that negative I'm going to move over. So it becomes -3 1 over u du. We? That's -3 natural log of the absolute value of u plus c, which is -3 natural log of absolute value of cosine plus c. You know? Now it's more common that the negative gets moved up. Oops, shucks. If you move the negative up, then it's log of cosine of the negative first, which is 1 over cosine, which is secant. This is truly the antiderivative of tangent, is secant. Log of secant. The antiderivative of tangent is log of secant. Cool? Are you with me? All right. Is it wrong to say -3 log cosine? No, it's true, but on a multiple choice test, you would see it. You'd see it that way. Okay. All right. 3 is 3 still a question? Okay. 3 is one of the course problems. 3. So this part might be my fault. I put the origin is at the top middle of the container. That's stupid. I meant the top left of the container. Was that the problem, or do we still need to talk about it? That doesn't help. Okay, top middle is stupid. That's ridiculous. All right, so say we put it at top middle. That's 60. This is 50. And this is 60. So force is rho dA. Rho is 4,500. What are the limits? If it's the origin is here, then what's the low and the high of the container? Okay. And what's the depth if I do surface minus y? And area, is that area constant dy, x dy, or 2x dy? Single x dy. We need the equation of this to sub for x. What's the slope? Up 60 over 10. So that's 6. What's a point? 60, 0, yeah? You with me? So y minus 0 equals 6 times x minus 60. Solving that for x, I would divide by 6 and add 60. Do you concur? All right, so then you're talking that x times the dy, and that gets you the force in A. You with me? All right. Should we talk about B? Right? If we put the origin at the bottom of the container, then that's here. Force is still 4,500 for rho. Now what are the limits? 0 to 60. Now what's the depth? Surface minus y. 60 minus y. Area is still base height, but now the equation's different. The slope is still 6. Now the point is 50, 0. So the equation's going to be more like y equals 6 times x minus 50. And therefore, solve for x, y over 6 plus 50 dy. Yeah? Okay, they should come out the same way you did something. Or we did. All right, 20, question on 20. 20 yay, 20 nay. All right, I assume 20, that worked out okay. Okay, 75, hit me.
1.
Too late, 20's gone. 75, 1,
1.
15. You want me to do 1 3 times or just once whole sheet?
25.
Okay, 25. 6. Did you say 10?
Yeah.
Did I hear 10?
Yeah.
Okay. All right, 1. Number 1. Hopefully that'll go better because we just did, oh, that's actually even easier. Woo. All right, so 1, if you read it carefully, it reads just like the one we just did, except it's easier because you don't have to write the quantity function. In 1, they just say write the revenue function, which is price times quantity sold. But as opposed to the other one, when I actually have to find quantity sold, they're giving you quantity sold. So what's the revenue function?
PQ.
PQ, and P and Q is? They give it to you. 1,500 minus 5P. Do they actually ask you to maximize revenue, or they just say write the find the price to maximize revenue? Okay, so revenue is 1,500P minus 5P squared. I think you'll agree that we want to find a max. Whether it's absolute or not is a non-issue because the max is not going to be at an endpoint. It's definitely going to be at the critical number. So R prime positive to negative, you could think relative max or absolute max. It'll work out just fine, but you should be good from there. Yeah? You can actually do that by graphing it, finding the midpoint between the zeros in a pre-calculus way. But calculus is good too. All right, 15. Question on 15. Oui, or no?
Yes.
All right, 15. Are we feeling U sub or inverse trig? With U sub. Definitely inverse trig with U sub. Okay, so would you divide out a 9 from the top and divide out a 9 from the bottom? When you divide out a 9 from the bottom, what does the denominator become? 1 plus 49/9 x to the 6th. We can finish questions on 75 tomorrow. 74B is substitute. Thanks, sir. Recorded the lesson. Thank you. Boom.